All right, welcome. Section 9.1, Pythagorean Theorem. Feels like we've been talking about it all year, but we finally get to the section that is actually entitled Pythagorean Theorem. I have a coupon to the side here just to kind of show. With every coupon, there's always the fine print. So if you take a look at this closely, it talks about only need to be a first-time customer, not good with any other offers. Most coupons you get, there's always a fine print. Dine out only, Monday through Friday, not good with any other offers. In the same way, it's important to note that the Pythagorean theorem here is only good for right triangles. So this entire chapter is going to deal with right triangles. And the first thing we want to get down is the fact that across from the right angle is the longest side called the hypotenuse. Right now, the two sides that create the right angle we're going to call the legs. We'll call this leg 1 and this leg 2. And so what we've been doing all year is Pythagorean theorem, which basically says leg 1 squared plus leg 2 squared equals the hypotenuse squared, or as we've been more accustomed to use, a squared plus b squared equals c squared. But the most important thing you're going to get is identifying right off the start, where is that c squared? Where is that hypotenuse? And making sure that that hypotenuse is on the side all by itself. So let's take a look at the first type of problem we will do. A real straightforward, find the missing length. So the first thing we have to do is identify the hypotenuse, identify that h, or in this case, the one that is going to be squared by itself. So in this case, we're looking at x squared plus 16 squared. We subtract 16 squared from both sides. 34 squared minus 16 squared equals 900. Now, if we look at the directions carefully, it says leave your answer in simplest radical form if necessary. So what that means is at this point, if I square root, we are going to use all the things that we just had done the previous 2 days with simplifying a square root if it's not a perfect square. In this case, if we square root 900, it's exactly 30. Let's take a look at the next one. First, identify the hypotenuse. 6 squared plus 9 squared equals x squared. So you can see two examples. It's not always just a squared plus b squared, where a and b are just the two numbers you're given. You must identify what's the hypotenuse and make sure that is the value right here that is on the side by itself. 6 squared plus 9 squared, we're looking at 117. And at this point, we square root, and 117 is not a perfect square. So now it's time to put into action what we learned the previous 2 days. Can we find a perfect square that goes in there? We have. It's square root of 9 times square root of 13. Square root of 9 is 3. 3 roots of 13. Final answer, x is equal to 3 roots of 13. Now, if you look at number 1, our missing side length was 30. That means we had side lengths 16 and 30 with a hypotenuse of 34. If all three side lengths are integers, meaning no decimals, no square roots, then that's something we have on this next slide called a Pythagorean triple. That's when all three of the sides of a right triangle are integers. And these are some of the most common ones. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. You'll find that in each of these four cases, multiples of those also work. So if 3, 4, 5 works, multiplying each of those values by 2, like we have right here, 6, 8, and 10, will also give us a right triangle. What that means is 6 squared plus 8 squared equals 10 squared. Same thing if we took all of those values and multiplied them by 3. 9 squared plus 12 squared equals 15 squared. That same rule applies through all four of these main Pythagorean triples that they give us. So if you're ever asked the question, is this a Pythagorean triple? Really, they're asking, are all three side lengths integer values? So that is part one.